Okay, ahead of tomorrow's test, I thought I'd go over a quick video just going through the reverse chain rule and just repeating it a couple of times using the trial method so that we really get into our heads how it works and a method for doing it pretty solidly every time. Well, one thing you need to know for integration is how to differentiate. So let's first of all look at our rules for differentiation that we learned via the chain rule. So if we have a function y that looks like f of x to the power of n, well, that would imply that y dashed, our differential, is the same as n lots of f of x to the power of n minus 1 multiplied by the differential of the inside of the bracket. That's a key one. What other ones do we know? We know that if y equals e to the power of f of x, some function of x, that implies that y dashed would be f dashed of x, e to the power of f of x, and then if we've got y equal to some ln of f of x, we'll leave it at this. That means that our differential y dashed would be the differential of the inside of the bracket over the inside of the bracket. So those are our three key rules. Make sure that those are memorized before the test so that you can recognize them first of all. If you know those, you can do this method. If you don't know those, you can't attempt it. In fact, you can't do integration altogether. So look back over what we've done before trying to attempt doing this. But now let's go through some examples of it. So the way it works is that we'll trial something, we'll differentiate that trial, and then we'll compare it to what we're actually trying to integrate. So the way I'm going to do this is I'm going to do this via a sort of grid method. So imagine that this is going to be my actual function. So let's say in this case, let's integrate a function like 2x plus 3 to the power of 4 dx. And then this side here is going to be my trial. So what I'm going to try then is I'm going to add one to that power, because if I look above at the rules, between these two here, the brackets, all I care about is what's inside the brackets. I'm adding one to the power. And so in all cases where you've got brackets and you want to do a trial, add one to the power of the thing that's making your life difficult. So in this case here, let's try to differentiate y equals 2x plus 4 to the power of 5. If we differentiate that using our chain rule above, we would get y dashed would be equal to 5 lots of 2x plus 4 to the power of 4 multiplied by 2, which is the differential of 2x squared, 2x plus 4 on the inside of the brackets. And now this is the key step here. What have I got then as a coefficient for y dashed? Well, 5 times 2 is 10. So how do I get from here to there? I need to divide by 10. And then those two would be equal to each other. And so if I need to divide that by 10 then, it means that my answer would be, the integral would be equal to 1 over 10 lots of 2x plus 4 to the power of 5. So this is where my divide by 10 has gone. Let me write that down actually in purple. Okay, let's try another one to get our heads around it. So draw another grid down. You don't have to do the grid, but I think for some people it might be helpful to make their working clearer. So what if we've got the integral now of something like x on the outside of x squared plus 1. And let's say this is to the power of minus 2. Well then, what we need to try is what's inside our brackets. So y equals x squared plus 1 with 1 plus 1 to the power, so that would be minus 1. If we try to differentiate this, y dashed, we'd get minus x squared plus 1 to the power of minus 2 multiplied by the differential of the inside of the bracket, which is 2x. So now I've got minus 2x, and all I've got in my question is x. So in order to get rid of our minus 2, which is the bit we don't want, let's do that in the same color as last time. In order to get from here to there, what step do I need to do? Divide by minus 2. So how does that then come into form? It means that our integral now would look like minus 1 over 2 lots of x squared plus 1 to the minus 1. So if you imagine, if you're doing minus divided by minus 2 for this one, we've also got to do it for this one, divided by minus 2. In our grid method, this here will be divided by 10. So that's all I've been doing. So I'm creating my grid, I'm doing a sort of crisscross method now for integration. Let's do another. So what if I now had the integral of something more complicated, let's say like 1 over 2x plus 4 dx? Well, we recognize that there is a differential form for ln of x, and the key part for the differentials of ln of x is that they're going to be to the power of 1. If it's something on the bottom bracket that's to the power of 1, assume you're doing something with ln of x, or with no power at all. So, in this case here, let's draw our grid down again, and let's do another one. So, in this case here, our trial would be ln of 2x plus 4. If we differentiated ln of 2x plus 4, differentiate the inside of the bracket is 2 over 2x plus 4. Well, in order to get from here to there, I need to divide by 2. These are all kind of division problems, aren't they? And therefore, I need to do the same here. I need to divide by 2, this. And so my answer would be a half ln of 2x plus 4. Let's do another. I'll send you the PDF of this as well, so that you can kind of practice. And try I'm making these up on the spot, by the way. These are just questions I'm thinking of. But let's do something slightly more complicated, like the integral of 10 over x plus 4 to the power of 3 dx. Well, x plus 4 to the power of 3 over that is exactly the same as doing 10 multiplied by x to the x plus 4 to the power of minus 3 using index laws. And so therefore, what do I need to trial? I need to trial x plus 4. I don't even care about the 10. I only want the stuff inside the bracket. That's the bit that's confusing me. And to the minus 2. And now let's try and differentiate that. If I put my trial as y equal to that, then my differential here would be minus 2 lots of x plus 4 to the power of minus 3. Okay, now I've got my minus 3 I've got in the question. Multiply by the inside of the bracket differential, which is just 1, so we don't need to worry about it. And now to get from here to there, to get from minus 2 to 10, I need to multiply by minus 5. And so therefore, whatever's here, I need to multiply by minus 5. And so my solution would be minus 5 lots of x plus 4 to the minus 2. And you can always check these by differentiating them. Okay, let's keep going. Let's maybe do one with some e's in there. So if we pick something with an e in there, let's say we're integrating x squared e to the x cubed plus 2. Let's do that. So our trial would be, well, let's think about it, looking up here. Well, we know that e to the f of x differentiates to f dashed of x, e to the f of x. So e to the f of x doesn't change. So if I were to circle the parts that we're sort of trying in these cases, we're looking for this bit formed from that bit in our trial. We're looking for this bit formed from that bit, and this bit, formed from all of it. Well, mainly from that though. And so in this case here, our trial would be just e to the x cubed plus 2. That's what's forming us difficulties. We can all integrate x squared. And so therefore the differential here would be 3x squared e to the x cubed plus 2, because the differential of x cubed plus 2 is 3x squared. And therefore, to get from the two of them, one to the other, I need to divide by 3 here. So if I divide by 3, guys, could you step outside, please, for a bit? I'm in the middle of a 20-minute recording for the DY2 students going through their paper. I'm in the middle of a 20-minute recording for DY2 students going through their paper. I can't pause it. And so therefore I need to divide this by 3. And so dividing that by 3, I would get 1 over 3 lots of e to the x cubed plus 2. That would be my example. Let's pick a few more as we go. Another one with e of x could be the integral of just e to x plus 1 dx, while trial would just be e to the 2x plus 1. If we differentiated that, y dash would be 2 lots of e to the 2x plus 1. So what do I need to multiply by? Actually, I'm going to do something like 7 in front of here, just to really confuse us. Doesn't matter what we trial then. Well, we need to get rid of our 2, and we need to get to 7. So we need to multiply by 7 over 2. Because the dividing by 2 will get rid of our 2, multiplying by 7 will get us the 7 we need. And so therefore I need to do the same here, multiply by 7 over 2. And so therefore I would get 7 over 2 lots of e to the 2x plus 1. On all of these, of course, you can't forget your plus c, plus c, plus c, plus c. But we don't worry about that really for now. But don't forget to put that down in your answer if there's no limits given to you. Let's do one more, and then I think we'll finish here. And let my3 into the class. So integral of, let's pick something really hard. X plus 1, let's say, over x squared plus 2x plus 1. Let's choose that, for example, dx. Well, what are we trialing? Ln of x squared plus 2x plus 1. Reason for that being is that this is all technically to the power of 1, or no power at all. Oh, what if we actually gave it a square root, because those are really common. If we gave it a square root then, well, first of all, we need to get it into a format that will work for this. So, let's give myself some space. So if we were trying to integrate the square roots, well, by our power rules, that's the same as integrating x plus 1 and x squared plus 2x plus 1 to the power of negative a half. So our trial would be negative a half plus 1. So y equals x squared plus 2x plus 1 to the power of, adding 1 to the power, a half. Differentiating that, y dash would be a half lots of x squared plus 2x plus 1 to the power of negative 1 over 2, and then the differential of the inside of the brackets, x plus 1. So how do I get in between the 2? I need to get rid of that over 2, so I need to multiply by 2 to get to here. Make sure your arrows are pointing the right way. And so therefore, my trial, I need to multiply by 2 as well. And so I would get 2 lots of x squared plus 2x plus 1 to the power of a half plus c. We've done quite a few examples. I'm going to leave it there. There's tons of stuff online about the substitution method if that's what you really want to do. But this is just so much faster. And there's so, I don't know, I find there's less room for error. Especially in notation and all the rest of it. But up to you. Please do give this a watch before tomorrow.